Good afternoon, folks. Frankentrain Labs, tuning smoke. Couple of revelations. The position of the sensor. Let's see if I can point this out to you guys. Nope, not on that one. Maybe I can on this one. Hold on. All right, apologies. There's a sensor, is that little orange piece of glass in there? That's a sensor, and then the heater is the heater, okay. And the orientation, as it is in this particular shape now, is the sensor is to the rear. And originally, in this one, I had the sensor to the front. And I just changed it to the rear because I found I had a better response time, and I want to show that to you. And what we're going to look at that is the temperature here is, well, no, that's the voltage. I bumped the temperature. Excuse me, I bumped the temperature thingy. It's very precarious. Okay, we're there now. Oh, he shut off on me. He's such a lazy bum. Just wants to go to sleep. Okay, so we have the temperature, and it's showing 95. It'll go around. It really doesn't matter what it is. We just want to look at its direction. Is it going up or down and that kind of thing? Because I'm not really in the chamber to know. And I've checked the chamber. The chamber is not soft. It's warm, but it's not overheating, okay? And so I've moved the location of the sensor to the back half. So it's sort of back here. Now in the chamber, you know, there's a fan and a motor here, and this is the back half of the chamber. So if it's in the back half of the chamber, that's where the air inlet, that black circle there, that's air inlet. So fresh air is coming in, and that's going to hit that sensor, and it's also going to allow it to cool off. So it's sitting at 4.77 volts on the heater coil, and that's because this chip is getting sensor information that says we don't want any more. Stop it. We're getting hot, according to where I was calibrated. So now I'm going to hit one puff, and you'll hear it. You'll see it and hear it, okay? Well, you didn't hear it, but you saw it. And it jumps up to 5 volts. One puff jumps up to 5 volts. Now I'm going to sit on it and just sit on it, okay? We're going to sit on it. Blow air. Blowing smoke, just blowing it flat out, and to tune of about 3 volts, I believe. I unplugged my meter, damn it. Okay, but look at the temp, look at the voltage, it's 6.1. So we're now reaching a very good saturation point for the heat to evaporate the oil. As you can see, that's a very healthy stream, okay? And if I'm puffing, look at that, I can get a ring going there. I'm puffing. You see that? And I'm sitting at 6. Yes. Now I'm going to stop puffing. The glare. Boom. It's dropping like a rock. Look at that. It's dropping. .4, you know, 4.5 was about, yeah, 4.5 was about it. So we're getting almost 1.6 volt variance between at rest and at full blast. And we're getting it in less than 30 seconds. And that's with an 8 ohm heater. Now I made some other adjustments to the whole thing, but this, what we have to remember is 8.2 coming in. The system needs 8.2 coming in to balance that out. If you go higher or lower, you're going to get a different thing. Okay, we'll see how that works later. And I'm running the fan off of another buckboard, so I can change it. I don't even know what it's at. I can try to find it if I get interested here. Let's see if I can find it without electrocuting something and blowing it up. That's not good. Oh wow, I'm up to 4 volts. 4 volts on the fan. I have to remember that when I go over to set up my chuff board, right? Okay, but look at that. I just hit it for a moment and it went up to 5 volts. I'm sorry about that glare. Let me get this light. Maybe that's better. Yeah, there. Well, maybe it's not. It's an overhead. It's the overhead. Oh, heck. So you hit it and it takes a while to calm down. Now I'm going to tap it. I'm going to say just tap it. So this is what I like to see is the instant response. And there we go. Puff, puff, puff. Get back here so you can see it. Get back here so you see it both. Puff, 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 puff. You're taking heat out now. You're making me a little chilly. I'm going to start jacking up the furnace. I'm going to start. Uh-oh, we're going faster now. I'm going to need more heat to keep up. We're going to cool down. We're going to lose the evaporation. We've got to add more heat now. You're going faster. I got to add more heat. I need more heat. That's all we got, boys. We're at 6 volts. We're cooking it. We're going flat out. We're going really fast now. That's my chuff signal trigger. But as you see, the faster we go, we're getting up to 6 volts, and 6 volts is really good. Now we're slowing down. We're coming into the station, and we don't want to overheat. We don't want to waste oil. We just want to come down. Okay, fine, look. Now, the thing with that is when we come into the station, in the board that we have, right now we're hitting this at 4 volts, which is great. But when we're in the station, we have a relay that triggers the circuit to another supply, and that supply has a trim pot on it, and I should be able to set that trim pot to 2.5, okay? And that means we're going to have less smoke. It's going to be a trickle, low speed, and it's going to get warmer, but it's not going to go up to 6. It's going to go up to maybe 5, 5.25. So you'll be trickling smoke at a low speed. And then when you take off, we switch over and we go to the puff side, which gives me full power. And when I get to full power, and I'm chuffing and I'm cooking, then that's going to get the voltage up to 6, and that's going to create more evaporation. And that, I learned 8, 7.5 was too low. 8 was just not quite getting us there, but the 825 is what gets me to 6. Oh, let's look at that amps. When I crank this up, look at the amp draw. Does it get to 0.8? Nope. 0.79. We'll call it 0.8 because I'm an industrial engineer and we round off. Now when I'm calming down, look at the amps. We're not doing anything. We're sitting here. We're idle. 0.6. So 0.6 to... Oh, heck. I hit something. There it goes. 0.6 to almost 0.8. So 0.2 of an amp draw on the power supply for heat. 0.2. That's not too bad. That's good for me to know. 0.2. Because of 6 volts times 0.2 is, oh God, my head. It's like 1.2 watts, I think, or something like that. So that's not bad. 1 or 2 watts, 1.25 watts. So that's how we're keeping the heat out of the plastic part, and we're not overheating the chip. Although the chip is warm, the thing here is we're sitting at 4, we're at 4.5, and that chip has to drain. When that's idle and we're not sending any signal, then this guy's getting hot and he's saying, close it down. He closes down the furnace by dissipating heat through his heat sink, which is a metal plate. And I've put this fin thing on to help him dissipate that. I wouldn't want to know what that... Well, let's find out. Let's find out. What is this temperature? Oh. Whoa. He's pretty hot. Well, he's not... No. He's not up to 90, but, you know, he's getting there. 90C is something else, right? Now, the temperature over here is something. it can get warm. I was getting 120 on the surface yesterday, and I knew I was overdriving a lot of things. But we're not there. This is a lot cooler today because I've got this a little more under control. I had it up to 9 volts, and I was doing some other testing. But I think moving that around helps me get the reaction that I need on the sensor. That just puts a smile on my face when it goes from 4 to 6, and it's cranking the smoke out at 6. That's exactly where you want this to be. And yet when you stop, the volt is there's no airflow. It's heating up in there. Here it comes now, and that's coming out of here, this boy. So you would like not to have so much, but you know, I don't know. I think we just don't get what we need for the smoke, is my feeling. See, we're already down. We're already down to 5.9. We're not